Greetings and welcome, friends. Today we are going to take our algebra to another dimension. We're going to talk about two variables instead of just one. We're going to represent these variables in a variety of different ways. You can kind of already see as what's called ordered pairs, as tables. We'll have graphs. It's going to be amazing. And yeah, we're going to be making graphs ourselves based off of equations. We'll be writing equations based off of graphs. We'll be plotting points on graphs using tables. Yeah, we're going to take the number line and turn it on its head. Instead of just a line, we're going to literally imagine if another line intercepted it like that, and you'd have an x-axis and a y-axis. Crazy. We're gonna, yeah, literally, we're adding another dimension, two dimensions total. So here we go. Let's take a look at this. A relation pairs inputs with outputs. When a relation is given as ordered pairs, the x-coordinates, okay, new language here, are inputs, and the y-coordinates are outputs. So for instance, here's what's called an ordered pair. It's in parentheses. It's called a pair because there's two of them. The first number is our x, and the second number is our y. All right? And a relation is just basically any relationship between x's and y's. All right? It could be the relationship between someone's age and their height. Right? Right? How much money you make per hour versus the number of credits you took in college. I don't know. It could relate anything. Anything. All right? Is what a relation is. Saying this is to that is really all it will be. A specific type of relation is called a function, and it's restricted. It has this rule. A function is a relation, so it's a subset of them, just like squares are a type of rectangle. The subset of them is a relation that pairs each input with exactly one output. All right, so here we go. Let's see if we can apply this rule in the following problem. It says this. Determine whether each relation is a function. Explain. Okay, so here we go. If I input -2, my output is +2, is what that's saying. Question, comment? Okay. Yep, so my student is saying that if the x value isn't the same, I think you're meaning like if it doesn't show up more than once, and yeah, that's the pattern that I think we'll see. Right. So notice this, I could plug in -2, I get a number back. I could plug in -1, I get a number back. I could plug in 0, I get a number back. I plug in 1, I get a number back. I plug in 2, I get a number back. Now, even though some of the outputs were the same, we're okay with outputs repeating. But as Adriana was saying, we're less likely to be okay. Most of the time, it won't be okay if the input repeats a second time or a third time or a fourth time. Basically, this is the way I like to think about it. Like when you're dancing at the club, the Boys and Girls Club, and the DJ says, I say -2, you say what? And then the audience, everyone would yell out 2 because they'd know that -2 gives us 2. Okay. Or if the DJ said, I say 0, you say what? And you're looking at this list up on his DJ screen. If the DJ says 0, what would the audience say? 2, right? 2 is the output when the input is 0. And everyone would agree. Everyone would agree. But how about problem B? If the DJ says, I say 4, you say... Some people would say 0, but other people might say 3. right? The problem is, in this case, that one input has two different outputs. So this is not a function. All right? So it is a function anytime everyone would know what the output would be based on the input. But once this input had two different outputs, it's like, well, half the audience might say one thing, the other half, or who knows, or some people might be just like kind of, I don't know, what do I say? I don't know, I'm confused. This has more than one output for the input of 4. And you can kind of see how that shows up based on the fact that, notice in example A, none of the inputs repeated, whereas in example B, you can see that the input of 4 repeated twice. And I want to point out once again, here, DJ, wow, there is no DJ here. DJ's a code name, apparently. So we're actually okay with the fact that this 2 repeated 3 times. It was an output. It didn't matter to us. We're okay that this 0 repeated as an output. That doesn't matter to us. What we're not okay with is when an input repeats. Okay? So let's see. Here's another way of representing this. This is just an input-output table. Sometimes, by the way, you'll see these tables written vertically as well. I could have written it as x and y this way, and I'd have -2, 3, and -1, 4, and 0, 5, and 0, 6, and 1, 7, and 2, 8. And at first glance for C, which I could represent, like I said, either way, function or not a function? Where does it fail to be a function? Right. Oh, what happened to my red here? There we go. Yeah. If I say 0, you guys are going to be unsure as to what to say. There's 2 different outputs, 5 or 6, and so it's not a function. Still a perfectly fine relation, right? That's fine. We're cool with that, but it's not going to be a function. So, not a function. Right? So it's just, for you guys right now, this just seems like some random rule that someone decided as to what makes a function or not, and that's fine, right? It's just, you just have to be able to characterize it and classify it. So here's like a little diagram where you can kind of see the inputs and the outputs. Let's see, what's the official name for these diagrams? I'm looking it up. It's called a mapping diagram, where you can kind of see which one points to what. Based on that, do you think it's a function or not a function? Function. Well, what about this 15? Do I have a problem with that 15? Yeah, it's an output, and we're okay if outputs repeat. But notice there's exactly one arrow leaving each input, so this is a function. Function. All right, let's, just because I have these and I think it's helpful to see these examples, let's categorize these as well. Actually, tell you what, let's take 3 minutes. So internet friends, you can just kind of hang out or fast forward, whatever. And my students are going to try to classify these right now. You could try this at home, friends. All right, so problem 1. Let's see, Ethan, if you could help me out. So these are ordered pairs, right? We've got x's and y's. X's are the inputs. Function or not a function? Thoughts? Nada? Why? Where does it fail? Where does it break down? 5, 0, and 5, 10. I've got the same input giving me 2 different outputs. No, not a function. All right. All right. How about 2? Let's have Amity. Yeah. Let's see. Function or not a function? For problem 2. Problem 2. Let's see. -4 always gives me 8. -1 always gives me 2. 2 always gives me negative. I think it's a function, right? It's a function because it has exactly one output for every input, right? Each of my inputs, if the DJ said, I say 2, you say, everyone would be like, -4, DJ, right? That's why I said DJ earlier. That was, maybe you're the DJ at the Boys and Girls Club. I figured it out. Mystery solved. You're DJ Mystery. All right, let's see. Question 3. Uja, if you could help me. All right, you're saying it's a function. I think I agree. Because for every input, there's only one output coming from it. Yeah. All right, last one. Adriana. You're saying no? Why? Yeah, this one input is giving me 3 different numbers. So when DJ says 1/2, everyone's confused. What do I say back? I don't know. Right? And we get scared. It's okay. So another way to represent relations or functions is graphically. Okay? And I think you've seen some graphs before. Here, maybe you should just put that on a different desk. It seems to be difficult for you to resist. So it's possible to represent relations or functions as a graph. And the way I think about this, so let's say this point, let's do this point right here. Let's say this point was over, let's call that like 8 units. And let's say it was up, I don't know, like 5 units maybe. All right, the point 8, 5 is an ordered pair x, y, and I would plot it, or think about it as being plotted by going over 8 and up 5. Okay, so instead of just thinking about it on a number line as a dot on a number line, I'm now thinking about it 2-dimensionally, where it's the point that exists at 8 for x and 5 for y. All right, so that's the idea. And you can plot points, or you can even plot like curves and swoops and lines and all sorts of things. And we'll be graphing some of those many things later on in this very course. But the question is, if I wanted to determine whether or not something was a function based on its graph, I could do that using what's called the vertical line test. Because the x-axis, remember, these are all inputs. And the y-axis are all the outputs. And so every input should only have 1 point above it, right? Every input should have at most 1 point above it. So this passes what's called the vertical line test. This would be a function. Because when I input whatever this number is, 6 or whatever, I get a number back, and only one number back. But this is not a function. Because when I input whatever this number is, let's say it's 6 again, I get 2 hits. Boof, 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 boof. Right? I don't know, is the output, say, 4 or is it 8 or something? I don't know. It's getting hit multiple times and I don't know. So this is not a function. Okay, so a graph represents a function when no vertical line passes through more than 1 point on the graph. So here's another way for us to determine functionality. Yes, I think so. All right, let's do example 2 here. We've already got someone who's given it a shot. The vertical line test. All right, thoughts for part A, Devin. Do you think I could draw a vertical line that would hit more than 1 point on this? Yeah. What x number do you think that occurs for? Or where's a case where it hits more than 1 point vertically? Looks like 5. 2 hits. Bam. And at 2. right? So 2 is giving me both an output of 2 and an output of 5. So this is not a function. Right. And you could say because 2 gives me more than one output or 5 gives me more than one output. How about B? Huh. Thoughts, Adriana? Function. Yes. Even though this has infinitely many points on this line, and this one only had like, what, 1, 2, 3, 4, 5, 6 points, this one's a function because every vertical line I draw, it's only 1 point. Bing, bing, bing. And I want to point out over here, notice this vertical line hit only 1 point. This was okay, but if it breaks down its functioning at even a single location, it's not a function. All right. But this one, I can't find a vertical line where it's not gonna have that happen. All right. These ones, now I know I gave you these ones. Right. Let's do monitoring progress 5, 6, 7, 8. 5, 6, 7, 8. Function. Function. All right. This is just my awesome house DJ music that I've got. Weird. Intriguing. All right. It looks like this is supposed to spell out a word. I thought I was going to say love for a minute there. Saw like an O and a V here. All right. I'm going to call in the cards of fate to have us volunteer our thoughts about function or not a function. And I draw the card, Jimmy, for question 5. Is there a vertical line that would hit more than 1 point? A vertical line. Let's see. Here's one. That hits 1 point if I drew it right. Is there ever a vertical line that could hit more than 1? I see a horizontal line that would hit all over the place, but we actually don't mind that the outputs repeat. We just don't want the inputs to repeat. So this one is function. These are all good. All right. Let's see. Ethan, question 6. What are your thoughts? Yes, it's a function. And this graph is called a parabola. We'll be graphing these later on in the course. But everywhere I draw a vertical line, it'll only hit at most 1 point. And by the way, just to clarify, this will never get vertical. All right, it never goes straight up and down because then that would fail all over the place. And it never like loops back or anything. Or it's just getting steeper and steeper, faster and faster forever, which is a terrifying concept perhaps for some. All right, I've already selected red, which can only mean one thing, Devin. Question 7. Do you think I could draw a vertical line that hits more than 1 point? Yeah. Like at 1, for instance. Bam! Multiple targets hit. Right? 4, multiple targets hit. It's also possible, I want to point out, I could, at 6, hit exactly 1 point, as well as at 0. These, by the way, these lines are called tangent lines, and they do exist in math, where it's a line that touches an arc or an edge or something like that at exactly 1 point, and it is possible. Also, do you guys think this is a problem? What about what's happening at 7 here? It hits no points. Right? We're fine if it hits no points. We just don't want it hitting more than 1. But it hit not a function. Let's see, Cameron, last problem. Do you think I could draw a vertical line on question 8 that hits more than 1 point? I don't see one. 1 point. Ding! 1 point, right? Seems to be that there's exactly one output for every input. This is a function. We'll also be graphing these sorts of graphs later on in this very chapter. These are called absolute value functions. Value like a V is what that kind of looks like, and that's the way I remember it. All right, here's another way to think about functions. Functions are like a machine where you input one thing and output another. All right, like a toaster. You put bread in it and out pops toast. You put a bagel in it and out pops a cooked bagel. All right, and so the domain and range of a function is the set of all possible things I could put inside of the function. All right, so the domain is everything that could go inside, and the range is everything that could ever come out. Is domain and range. And just because, it would be worth figuring out what you can and can't put in a toaster, right? Like if I wanted to boil water for my ramen noodles, could I just like pour some water in a toaster and like just push? No, don't do that, all right? Whoever's watching this at home, stop right now. Don't do that. No, that a toaster, although it can heat up and toast breads of all sorts of varieties, don't use it to boil water. It will not work. So water would not be something included in the domain of possible inputs for a toaster. Yes. I have not tried that. Although I think I saw a video just the other day about two guys who put steak in a toaster and cooked it like 8 times, and then it came out awesome. It probably will also get your toaster all greasy and such. And then the range are the possible things that come out of the function. All right. So let's talk about domain and range. So this is about possible inputs and outputs. What is feasible? What is permitted? Okay. So graphically speaking, if I want to figure out the domain, which letter, is it X or Y, represents input or output? X is the input. Yes, thank you, DJ Devon. Sorry, I let your secret identity get out, but it's okay. It's not like you're Batman. So the x-axis is the input. If I want to find the domain, which is possible x's, the way you could think about that is, what if I smushed all of these points down to the x-axis? What points would those be? And so the domain, we can actually write it in a few different ways. I'm going to write it, I'm going to use set notation for this. I'm going to say that the domain is the set of all x. This is like a curly bracket thing. The set of all x, and then I do like one vertical line, like an absolute value bar in size. This literally means the set of all x. This is math, like shorthand. Like this is how mathematicians text each other about domain. The set of all x, and then this vertical line means such that, is what that means, okay? And you could say, oh, actually, man, this is a bad example. Because x is very specific numbers here. Man, all right, well, I'm going to rewrite it down here. Because there's only a finite number in my list, I'm just going to say x could equal -3. X could equal -1. X could equal +1. And what's the other number that x can be according to this graph? What's the other possible x value? Boo, boo, boo. 3. And because these were exact numbers in a short list, I didn't want to... This is good for describing like what we'll have over here in a moment. So let's see. So I'm going to say for over here, the domain is the set of all x such that... And if I was to smush this down to the graph, I would get -2. If I was to smush this down to the graph, I'd get positive 3. I could smush this down, but I could also smush like this point down, and this point down, and this point down. Question, comment? That x is describing the x-axis. The 3 is describing where on the number line that is. Yeah, that's a good point. Yeah, so those are separate things. But notice if I smushed every point down or up, I would end up getting the domain as being everything between -2 and +3. And we actually have a way of writing that, because there's infinitely many points there. I'm going to say it's the set of all x such that -2 is less than or equal to x is less than or equal to 3. So that would be the domain for this function. Everything between -2 and 3. Another way you can write this, by the way, I could say the domain is -2, 3 with square brackets. And that means includes 3. This is like a less than or equal to part. We'll get some more experience with these. Let's talk about range. So range are going to be the possible y values. And so I could imagine, what if I smushed these all to the y-axis? And so notice for this first graph, I get a possible output. The range is going to be this set. It looks like -2 is a possible output. What's another possible output on this y-axis? 0. We might as well go in order. What's the next one? No? For the y-axis, it hits at 2 and 4. Right? So those are the possible outputs. So here's the possible inputs, possible outputs. And how about for this one? Watch if I smushed this over to the y-axis, I'd get a point here. And if I smushed this over to the y-axis, I'd get a point there. And I could smush all of these points, and I would end up getting everything in between these values, which, what's the smallest y value it would ever give me? -1 all the way to +2. So my range, I could say, is the set of all, gross, y such that y is between -1 and 2. So let's write between, right, these two numbers. -1 is less than or equal to y is less than or equal to 2. Right? It's going to take a little time for us to get used to writing things like this, and that's okay. Yeah, they're going to have all sorts of crazy looking graphs, but fortunately we don't have to know the equations of those graphs yet. Yeah, some people say today felt like Monday. All right, another term for us to be aware of. The variable that represents the input values can be called the independent variable, because it can be any value in the domain, right? I pick the input, right? I pick the bread going into my toaster. The toaster didn't force me to do that this morning, right? But once I put bread in there, what comes out of that toaster when bread is inside is only going to ever be one thing. And the only way that that is determined, it depends on what the input was. All right, so that's the output is called the dependent variable. So dependent is the output. The independent variable is the input. Okay? So here is another way of representing a function. And actually, you didn't even know this was a function yet. This could have just been a relation. But another way I could describe a relationship between inputs and outputs, or x's and y's, is with an equation. I could say y is equal to the opposite of whatever you give me plus 10. So this would be like a function. It is a function. Right? You give me a number and I'll tell you the output, is the way that this works. So let's do example 4 together. I give you a problem, you solve the problem. Here we go. All right, so we've seen today ordered pairs, we've seen mapping graphs, we've seen actual graphs, we've seen equations, right? We've seen a whole bunch of different ways of representing relationships between two pairs of numbers. Here it says the function y equals negative 3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x many gulps. So A, it says identify the independent variable and the dependent variable. All right, so the input is going to be the x. So the independent is x, or the number of gulps. Gulp. And the output is what this is going to be, equal to. After I do a bunch of little beep, boop, boop, beep, boop, multiply by negative 3, add 12, I get an output from my function, y. And that will be my dependent variable, which is the fluid ounces left in the beverage. Okay. And then they say the domain is 0, 1, 2, 3, and 4. What is the corresponding range? And to do that, we are going to actually make a table. Yeah, and eventually we'll have far better ways of doing this than with a table. But I'm going to make a table here. I'll have my inputs in one column. So 0, 1, 2, 3, and 4. Which is what? The number of gulps. I'll have a column for my work, which is going to be negative 3x plus 12. And then I'll have a column where I write my output y. All right, so let's do some work. If I plug in x for this function, I would have negative 3 times 0 plus 12. And now I'm just going to PEMDAS this. Negative 3 times 0 is 0, and 0 plus 12 is 12. So when I input 0, the output is 12. If I've taken 0 gulps, I have 12 ounces of fluid left in the glass. Now let's plug in 1. Negative 3 times, I'm plugging in 1 for x. Negative 3 times 1 is negative 3. Negative 3 plus 12, same as 12 minus 3, it's 9. Right? So I input 1, output 9. Input 2. Nope, I wrote it too quick. Negative 3 times 2 is negative 6. Negative 6 plus 12 is 6. And then we just go from there. Negative 3 times 3 is negative 9. Plus 12 is 3. And plug in 4 for x. Negative 3 times 4 is negative 12. Add that to 12, I get 0. How many ounces do I drink per gulp? Side question. Looks like 3 ounces, right? Every gulp, it's going down by 3. And question, what is the range? Right, the range is going to be all the possible outputs. And since these aren't everything between 0 and 12, these happen to be exact numbers, I'm going to say 0, 3, 6, 9, and 12. All right, that would be the range for this problem. Unless they said I could take like a half of a gulp or a third of a gulp, then I might say that the range is everything from 0 to 12. But let's see. I think I'm good. All right, thanks for watching, internet friends. Bye-bye.